The purpose of this project was to understand how integrals and cross-sections are used to determine and calculate the volume of a solid. I began my project by graphing the functions that make up the outline of the shape I chose. Using a printed photo of my shape, I chose 2 regions and took the measurements for the different sections. For the semicircles, the measurement taken represented the diameter, while for the triangles it represented the hypotenuse. I then measured the width of my material. Using this, I was able to calculate the radius and the area of the semicircles, which allowed me to calculate the volume. I was also able to calculate this for the triangles. I then drew, cut, painted, and pasted the series of shapes, the semicircles perpendicular to the x-axis and the triangles perpendicular to the y-axis. The next part was one of the hardest, scaling. I measured the same part of the Desmos and the model to determine the factor. I used this factor to find the place in my Desmos graph where my sections began and ended. Next, I calculated the theoretical volumes of each wing. I divided my right wing into 2 parts, each one bound by different functions. I wrote a different integral for each. To do this, I needed to rewrite the functions in terms of y, since this was perpendicular to the x-axis. This information allowed me to write the formula for the volume as the sum of the integrals for the 2 regions. I then began the same process for the left wing. The radius of the circles was the difference between the 2 functions. Once again, I divided my area into regions based on the different functions that bounded them. For this part, the bounds of the integral would be values of y. I divided the wing into 3 separate regions. My next step was to write the functions in terms of x, since this was perpendicular to the y-axis. However, I was unable to do so for 2 of the functions. I substituted these 2 functions with the colors of the Desmos in order to write the formula for the volume. In this section, the hypotenuse of the triangles is determined by the difference between the 2 functions that bound each section in terms of x. I chose this superhero because I really like the movies and because his is the story of a man who overcame his difficult past in order to become a successful and better person. Although his is a classic underdog story, I think the principles of changing into a better person should be the aspiration of each and every one of us. The difference between the theoretical and the physical values was quite high because I used a very thick cardboard in order to do my physical cross-sections. Although this project was quite hard and time-consuming, I really liked it. I like being able to visualize math and especially build it. However, I do wish we had more time, and that was perhaps the part I struggled with the most.